What's up, all you mathematicians? Happy day 13 of at home learning. I hope everything's going well. Today, we're going to finish up the last two objectives of section 2 on compound inequalities. Today, we're doing the union of two sets. So, yesterday we did intersection, so that was, what belonged in both, what was the overlapping area. Union is just mixing everything together. So anything that's in either one of them all goes together. The symbol for union is the U. So I remember the intersection looks like kind of like an N, and there's the letter N and intersection. Union definitely looks like the U for union. So just like yesterday, we're going to start with a couple of sets of numbers. They're asking us to find the union of A and B. So it says A is the set of x such that x is an even number greater than 0 and less than 10. So again, let's define that. A really is the numbers 2, 4, 6, 8, and that's it. 10 would not be included because it's strictly less than 10. B is the set 3, 4, 5, and 6. What is the union of A and B? So again, union is if it's in A or if it's in B, the union is everything mushed together. Intersection was what was in both. The union is what is in each of them all mushed together. So if A is 2, 4, 6, and 8, and B is 3, 4, 5, and 6, we're going to put them in order from smallest to biggest, and anything that's in both we're just going to list once. So 2 would be the smallest. There's a 3 in B, 4 is in both, 5 is in B, 6 is in both, and 8 is the last number. So it's everything in A and B. We like to put them in order from smallest to biggest, and anything that's in both we only list once. So we only put the 4 and the 6 once. We'll do a couple more. A is that same set. B is an odd number between 0 and 10. So let's define that a little bit better. B is 1, 3, 5, 7, and 9. C is 2, 3, 4, 5, and D is 13 through 16. Find the following sets. So what is the union of A and B? So A is 2, 4, 6, and 8. B is 1, 3, 5, 7, and 9. So if you were to put the union of A and B, it would be everything. So it's going to be 1, 3, all the odds and all of the evens. So it's going to be all of the numbers between 0 and 10. 1, 2, 3, 4, 5, 6, 7, 8, and 9 when you put them all together. The union of C and D. So again, what's in C? 2, 3, 4, 5. What's in D? 13, 14, 15, 16. So we just put them all in there. None of them overlap, so we'll just list them in order from smallest to biggest. And then lastly, the union of A and C. A are 2, 4, 6, and 8. C is 2, 3, 4, and 5. So in order, 2, 3, 4, 5, 6, and 8. Let me know if you have any questions on that. So it's just everything listed out. So that is going to kind of lead us into compound inequalities that have or in between them. So or is going to be everything and everything, okay? So the or statements will never be mushed together like those last examples we had yesterday. It's always going to have an or in between them. So just like yesterday, we'll solve each of these inequalities separately. So we would add 3 here. 5x is less than or equal to 13. Divide by 5. It doesn't go into it evenly, so it's 13 fifths. By the way, just for whenever we go about doing that on a number line, that's 2.6. The other one is very easy to solve. Subtract 1. X is greater than 4. So we'll make, just like yesterday, we're going to make 2 number lines for each solution. So 13 fifths is smaller than 4, so it would go on the left side of the number line. So we'll make 2 number lines with those 2 values on it, 13 fifths 4. Okay, my red solution is x is greater than 4. That would be an open circle shaded to the right. My other one is x is less than or equal to 13/5. So that would be a closed circle shaded to the left. So because it's an or statement, our final solution is going to be anywhere we've shaded previously. So our final solution is going to be that 13/5 and the 4, and it's just going to be those kind of put together. So then we have to write our final inequality, and since they are going opposite directions like this, we're going to say x is less than or equal to 13/5 or x is greater than 4 because they went opposite directions. So that's how those will look. Let's look at another example there, number 2. Start by solving each equation or inequality like before. Divide by 8 and x is less than 3/8. Over here, just have to add 1. So it looks like x is greater than or equal to 3. So we'll put those on a number line real quick. 3/8 is less than 1, so it's going to be on the left of 3. That would be a closed circle on 3, shaded to the right. And for my green solution, it would be an open circle on 3/8, shaded to the left. So it's just like the last one. We take, if anywhere is shaded, we take it for our final number line. So it's going to be an open circle on 3/8, shaded to the left, closed circle on 3, shaded to the right, and then we just write down those inequalities. X is less than 3/8, or x is greater than or equal to 3. Let's do some more on the back. Just a couple more. Nice and short notes today. Congratulations. Easy to solve here. Add 5. Negative 2x is less than 8. Divide by negative 2. Remember, when you divide by a negative number, it flips that inequality, so it's going to be x is greater than negative 4. My second one, just have to divide by 6. X is less than 0. All right, so let's put those solutions on a number line. Negative 4 and 0 go on my number line. My red solution will be an open circle shaded to the left. My red solution, I would have negative 4 and 0 still. I'm going to put an open circle on negative 4 and shade to the right. So notice, when we combine them, everywhere is shaded at least on one of the number lines, right? It's shaded from 0 to the left and from negative 4 to the right. So if we put it all together, everything would be shaded. So what does that mean if everything is shaded? That means you can pick any number, so that's going to be all real numbers. So that will happen sometimes. On and statements, sometimes you get no solution. On or statements, sometimes you'll get all real numbers. We have one more example to look at. We're going to start, of course, by distributing that 3. So 3x minus 3 is less than 12. Add 3. 3x is less than 15. Divide by 3. And x is less than 5. My second one, just have to subtract 7. And x is greater than 3. Put them on a number line. My values are 3 and 5. For my red solution, I would have an open circle on 3 and shade it to the right. For my green solution, I would have an open circle on 5 and shade to the left. So it's just like the last one. You'll notice everywhere is going to have some kind of overlap. So our final solution would have everything shaded, and it's all real numbers. I want to hit one more type of scenario that you would get that I didn't have an example of. So let's say you got a solution that says x is greater than 3, and a second solution that x is greater than 5. So what would that look like? You put 3 and 5. So for my red one, I would have an open circle on 5 shaded to the right. For my pink one, I would have an open circle on 3 and shade to the right. So if you were to combine those, where is it true for at least one? Or if you just kind of mush them together, what would that look like? It would look like this. I would have an open circle on 3 and then everything shaded to the right. So what would that condense to? That would just condense to, what does that number line look like? It looks like x is greater than 3, open circle, greater than 3 to the right. So if they're going the same direction, it'll combine to just one normal looking number line and solution that you can combine to just one inequality. Let me know if you need any help while you're working on your My Math Lab assignment. I'd be happy to help you out. Tomorrow we'll start with our review and get ready for a quiz over this section. We'll talk to you soon. Have a great day. It's a great day to be a mathematician, y'all.